All right, so to finish up section 3-2, here's the rest of the story. Here's what else there is to know about using the substitution method or the elimination method. And so this basically picks up where the last video left off. And if you saw that last video, Mr. Burchanowski snuck into my room and he got involved, and he was actually asking this question, you know, this question that no doubt has been eating at you since we started solving systems algebraically. You know, what happens when there's actually no solution or infinitely many solutions? Because remember, a system of equations could have one solution, which admittedly happens most of the time in high school problems. But you could also have no solution or infinitely many solutions. And we know how to recognize that with the graphing method. But what happens if you work on a system that is one of these two scenarios and you're doing either substitution or elimination? What happens? Okay, so let's figure that out. Let's investigate how to recognize that with substitution or elimination. So activity. Create a system that you know represents two lines that are parallel. Thus, the system will have what? If the two equations are going to be graphed as two parallel lines, how many solutions are there going to be? No solutions. So feel free to do that right now if you think you can. If you think you can come up with two equations, two random equations, any two equations you want, that you know are going to be graphed as two parallel lines. But I will write my own in 3, 2, 1. So maybe you came up with a pair of equations that was like y equals 2x minus 5 and y equals 2x plus 4. You know, something like that. Because these two slopes match and therefore would make parallel lines. And then, so let's see. Solve it using the algebraic method of your choice. Now, I look at these two equations, and what I'm going to choose, you don't have to do what I'm doing, but I'm going to choose substitution, which, since both of these equations are set equal to y, the substitution method is essentially going to be setting these two equations equal to each other. So we have 2x, 2x minus 5 equals 2x plus 4. Again, this is technically the substitution method. All right? So let's keep this going. What would we do next? We would solve for x. We would, in this case, we'd have to get both x's on the same side. So we do that, and oh darn it. It cancels so. And what we are left with is negative 5 equals 4. The x variable completely went away. And what was left over is negative 5 equals 4, which is either true or it's false. In this case, it's blatantly false. And I hope you remember from stuff you've done in the past, maybe even in this class, but Algebra 1, maybe some junior high math, whatever. Uh, the fact that you end up with a false statement, this is always false. What you say is that, okay, there is no solution. So maybe you want to write down that this is false, because that is the indicator that you conclude that there is no solution whatsoever. So that's what you're pretty much going to be seeing, okay? And this type of thing would have happened no matter what two equations you would have picked, that would be parallel, or even if you would have chosen to do the elimination method, you still end up, at this sort of event. You still end up with a false statement, and therefore you conclude that there is no solution. So that's how you figure out that there's actually no solution. You get a false statement. But in the other situation, create a system that represents two lines that are actually the same line. Thus, the system will have how many solutions? If the graphs would end up being two lines right on top of each other, you would have infinitely many. So perhaps you can come up with that on your own, can you? Two lines that are actually the same line. So maybe you said like y equals negative 3x plus, 7. And if you wanted to just be like super blatant about it, then the other equation would literally be y equals negative 3x plus 7. But couldn't I move some things around, for the other equation so that they weren't blatantly, obviously the same, they were the same equation, but it was kind of in disguise. So I could move this term to the other side, and I could write down 3x plus y equals 7. Positive 3x plus y equals that positive 7. But maybe I can even make it even less obvious. Maybe I can even make it less obvious by taking the, 3x plus y equals 7 and maybe multiplying everything by 2. And so therefore it would be 6x plus 2y equals 14. So now when you look at these two equations, it's not nearly as obvious that they actually are the same two equations. So there we go. So that's my system I'm going to use. And so let's solve it using the algebraic method of your choice. So here, look, once again, I find myself looking at this system, and I want to choose substitution because one of the equations is telling us what y equals. Now, you could move things around and line everything up and then use the elimination method if you wanted to. But it's not going to matter too much. It's still going to be the same teaching point here. So let's say we did substitution. And so y equals negative 3x plus 7. So I'm going to plug that whole quantity in for there. I'm going to squeeze it in there. So 6x plus 2 times the entire quantity of negative 3x plus 7 equals 14. And so now I can just go from here and let this play out. Distribute the 2. Pen and board acting funny. And so look what happens here. Once again, the variable, in this case it's the x variable again, completely cancels out, and it's gone. Because this is like 0x, or 0. So it's gone. And what you're left with is 14 equals 14, which is either true or it's false. But in this case, it's completely true. Another common, like, final sort of answer here, not final answer, but another common thing you end up with is 0 equals 0. Like, I could actually take this one step further. Like, what if I subtracted 14 from both sides? I'd end up with 0 equals 0, but that's also true. So it's the same thing, It's true. And when you end up with, like, the variable completely canceling out, like completely on both sides, and you end up with something that's, like, true, that's where you conclude that there is infinitely many solutions. And again, let's say you would have, like, worked this around and did the elimination method, you still would end up with, like, the variable totally going away and ending up with something that is, like, true. All right? Heck, I'll even show you. You don't believe me? Okay. So if I were to take this first equation and try to line everything up, this would become 3x plus y equals 7. And, this would be 6x plus 2y equals 14. And so in order to make opposites, like, let's say I wanted to turn the x's into opposites, like, I could literally multiply the 3 by 6 and the 6 by 3, or I guess it'd have to be like -3, right? But if you're really on your toes and you really get this, and you can, like, think about this, like, pretty strongly, I can just look at this and go, well, all I have to do is multiply that 3x along with everything else in the equation by -2. Okay, and I can leave the second equation as is. So this system becomes, well, this equation becomes -6x. So I'm going to draw, like, a little arrow here. -6x minus 2y equals -14. And so now when I add these two equations, see, this equation, don't cross it out like this, I guess, but now I have this two stuff. So now when I go ahead and add these together, these obviously cancel like I intended, but so do these. And you end up with essentially 0. And over here, 14 plus a -14, 0. And you end up with, like I said, 0 equals 0, but that's true. And so you still end up with this same final answer of infinitely many solutions. Now, like I said a couple videos ago or something, this doesn't necessarily mean that anything is a solution. Like, it's not like every single XY pair you could come up with is a solution. It's only the infinite. Isn't that funny? It's only the infinite. It's only the infinite number of XY pairs that are on these lines, because they're like the same line. But anyway, that's what happens. Remember, the variables totally go away. You end up with something that's false. Then you say that there's no solution at all. But if you end up with something that's true, you say that there's infinitely many solutions.